While attending a program at the Monroe Institute, I was introduced to Tom's My Big Toe. Each chapter opened my mind to whole new vistas of thought. While I was reading the book, which took me several months, the opportunity arose for me to attend Tom's 2-day workshop in New York. I chose to give myself the gift of being able to attend, and I'm so glad that I did. Your decision to attend this event is a gift you will really be able to appreciate when you look back on it from a future perspective. For those of you who are note takers, Tom makes all of the event slides available on his website, mybigtoe.com. By listening openly to what Tom is about to share with us, you will be able to absorb the concepts. Sitting in Tom's energy and allowing yourself to absorb his wisdom will be beneficial on many levels. I measure my own growth now in terms of BT and AT, before Tom and after Tom. It is my sincerest hope that you will get as much or more out of this event as I did from my weekend in New York. Ladies and gentlemen, Tom Campbell.
Thank you, Beth. Hey, welcome, ladies and gentlemen. I'm Tom Campbell. This is Reality 101, one of 3 days. It's good to be back in Calgary. I was here last April, and it's a beautiful, beautiful place. Before I get started, I'd like to thank Beth Haley. She was just the one speaking to you. Cheryl Guglielmi, Tim Kaiser, Mike Finch, Daniel White, and Sean Booz for helping pull all this together with Beth and Cheryl. Their energy, their vision has created this opportunity for all of us. This is going to be short tonight. I'm trying something new for the first time, and that is this Friday night is going to be a quick overview of the whole workshop, the whole 3 days. So there's about 130 slides, and I pulled out about 24 of them for this, and we're just going to skip and jump through the presentation so that you get a good idea of what I'm talking about in a real short period of time. And there should be plenty of time for questions at the end of this on Friday. On Saturday, we'll still have time for questions again, and then by Sunday evening, the question answer period should be long. We should maybe have as much as 2 to 3 hours for questions on Sunday. But I will ask you to hold your questions until we get to after the break, and then it'll be a question time, because otherwise this topic stirs up so many questions that we'd never get past the first question and answer session if we didn't hold it to the end. Saturday, tomorrow, I'm going to give a much more detailed presentation of many of the things you're going to hear tonight. So you'll get a lot more of the reason why does it work that way, some explanation, more detail. You'll understand it, I think, a lot better. These ideas are simple ideas, but they're hard to grasp because they are different paradigms. You have beliefs about the nature of reality, and these aren't intellectual beliefs. These are beliefs down at the gut level, down at the blood and sinew level. This is the kind of belief, they're cultural beliefs about this being an objective reality. And things I'm going to tell you will explain to you that this is not an objective reality, and I'll try to explain how and why that works, but it's going to be hard because all of those habits of thinking are going to be there as blocks in your way. Saturday will be mostly theory. How and why does it work? What's going on? What is reality, and what are the mechanics of it, and how do you relate to it? At the end of the day Saturday, we're going to do what I call experiential exercises. I keep telling you throughout my talks that you have to experience this yourself. This is not something that you can get intellectually. It's something you have to get through your own experience. So the way you get experience to understand and to know that this is real, that reality is really the way I'm explaining it to you, and that these experiences that seem to be non-objective are actual real experiences, is through your own experience. So I'm going to teach you something about healing with your mind and I'm going to teach you something about remote viewing. And the reason I picked those two is they're both easy to do. Anybody can do those with just a little bit of practice. It's not that hard. So I'll give you some experiment. We'll go through some exercises. We'll do some experiments. And if you were to practice then for, say 6 months, if you were to practice every day for 6 months, you'd probably end up being fairly good at it. It's just not that hard. And this is how you get to collect evidence that what you're doing is real, that it has a real effect in this reality. You can get the mind-physical connection, evidence that you need. I like talking about the theory because I'm a physicist and what I do is theory. But besides that, if you understand the theory, then it's much more easy for you to understand the application. If you don't understand how it works, then working with it, learning, experimenting, and growing with it is very, very difficult if you really don't understand what's happening or why. If you know the rules to the game, you're a much better player than if you don't know the rules to the game. So that's why I like to spend a lot of the time on the basic theory to get you to understand the nature of reality and how it works. Okay, Sunday we're going to talk about the larger reality system, how to get access to it, what it's like, what to expect when you get there, interactions, reactions, what it's not, what you can and can't do, and that sort of thing. So that'll be on Sunday. And then at the end of Sunday, we'll do another experiential exercises where we'll do some more healing and remote viewing. Because by then you'll have learned a lot more and you'll approach it from a little different angle. Now about the slides are very wordy, but they're wordy on purpose. They're wordy to try to capture a lot of the information. You don't really need to read all the words. I'll tell you everything that you need to know. You can just ignore the slides altogether. If you can't see them very well, it's not a big problem. But if a day or two or a week later, it all starts to fade and you'd like a little reinforcement of what went on for your memory, these slides are at my website, as Beth said, and you can download them and basically have a record of what's said. I would like to have a little idea of my audience, of what it is you know and understand, kind of where you are, so that I can say things in a way that work good for you. I'd like to ask you, how many have seen at least one of the YouTube's videos that I do? Oh, this is going to be a smart audience. You already know. Okay. Any of you seen more than one? Good grief. All right. This is an advanced class. Okay. How many of you are mainly right-brained and intuitive? Oh, that's surprising. How many are left-brained and logical? Oh, it's about 50-50. All right. How many of you have already had out-of-body experiences or know how to heal with your minds or remote view or that sort of thing? Yeah, good. Okay. And how many have never done those things but would like to learn how? Yeah, it's about split too. Okay. Thank you. That helps me. All right, I'm going to make the introduction very short. About 2/3 of you have seen the videos. If you've seen the videos, you've heard all this before. You're going to hear it again. The good news is that sometimes hearing it again is helpful. So I'll try to keep this short. One of the first things I like to start with is what you need to do as far as you're listening to what I say is not believe me. Don't believe me, please. Okay? That's a strange thing to say, right? Whatever I tell you, don't believe it. Whatever I tell you, don't disbelieve it. Believing or disbelieving is irrelevant. It just doesn't get you anyplace. Okay? Remain skeptical, but remain open-minded. Open-minded skepticism is the only thing that can ever take you anyplace important. Whether you believe what I tell you or disbelieve what I tell you is of very little value. What can you do with that? How can that belief help you grow? How can that belief help you move toward love? It doesn't. If you're skeptical and open-minded, you'll go out and find out. You'll do some of these exercises. You'll convince yourself of whether it's real or not. Then you'll realize that growing up means becoming love and that it'll be important to you because you've been there, you've seen it, you felt it, you're a part of it. So it's not about belief. If you're here to decide whether or not you should believe me or not, that's the wrong approach. You should be here to be skeptical, to listen and be open-minded, and then to go out and try, to do it. Don't just, that was nice and interesting, walk away and forget about it, because then the opportunity will be wasted. So what I really hope to get is to get you interested enough to go find out for yourself. If you're skeptical but not open-minded, you risk being a fool, because only a fool would believe himself to be omniscient. If you're skeptical but not open-minded, what that says is that you think you already know the answers. You say, you don't need to be open-minded, you know the way it is. Well, you can never learn anything with that. On the other hand, if you're open-minded but not skeptical, you risk being a fool, because only a fool would believe anything they hear or everything they hear. So you have to be skeptical. You have to make it your own. It's not your truth until you've experienced it. So who am I? I'm a scientist. That probably characterizes me pretty well. I'm not right-brained or left-brained. I'm kind of a blend of both. Neither one, I think, is particularly dominant. I'm a scientist, and many people would say I'm a mystic. But I think I'm just a scientist who has brought mysticism into science. My research was in experimental nuclear. I never actually worked in that field. I worked as a contractor, national missile defense, and sensor systems, technology development, software engineering, that sort of thing, systems engineering, integration, vulnerability, risk analysis. Now I'm a consultant. And what I do as a consultant is I do risk analysis on complex systems. And as a consultant, I work sometimes and don't work. I've actually retired 3 times, and I'm hoping this last one will stick, which means the consulting jobs will thin out a bit. It's my hope. But what I do, the last one I had was with NASA, ran for about 1.5 years or so, and I was on the team that was putting together the replacement for the shuttle. My job was, and not just mine, but mine and a lot of other people, we all worked as a team, was to find out what could possibly go wrong, what's the probability of it going wrong, and if it does go wrong, how do you deal with it, or how do you prevent it from going wrong? So it's basically a big system analysis. So you have to describe the whole system, and there's tens of thousands of parts produced by thousands of different contractors that all have to work together. It's a very complex system that sends a man up into space, very complex. And if a little sensor, a little piece goes out over here, that may not seem too important, but then that'll affect something else, that affects something else, that affects something else, and 10 cycles down the road, you have the thing, it blows up, or it doesn't respond, or there's some kind of problem. So tracking how all of these things happen, because if number 1 affects number 2, 3, and 4, each one of those, 2, 3, and 4, affects 10 other things, and each one of those affects 10 other things, and it just radiates out through the system. And to find out what's going to break and what the risk is the kind of work that I do. So that's what I do in the real world. Okay, now how did I end up here? Shortly out of graduate school, I got connected with Bob Monroe. Bob Monroe was just setting up, I don't know, everybody here know who Bob Monroe is? Do I need to explain that? Yeah. Okay, Bob Monroe wrote Journeys Out of the Body, and then 2 other books, Far Journeys and Ultimate Journey. And those described his experience in this out-of-body phenomena. And Bob's books got real popular because Bob was the first one to do this without any kind of preconceived notion. There was no theory involved in it. There was no, it was just a journal. Here were my experiences. Listed them down, just like he was taking notes, and then that's what he published. These were my experiences. He didn't comment on the theory of any of it. Okay, they were very popular books. When I met Bob, he was just in the process of putting together a laboratory to study consciousness. And Bob's motivation was that he wanted to be more acceptable. He wanted to have more credibility. He knew what had happened to him was real, but he wanted it to be science. So he wanted to study consciousness and find out just how did this work and could he teach other people to do it. So he wanted to build this lab, and I bumped into him at that time, so did some other people. A friend of mine, Dennis Menrick, I'm a physicist, he was an electrical engineer. So we made a swap with Bob that we would build his lab, we would do the equipment, we would do the research, do the protocols for him, be his in-house scientists if he would teach us everything he knew. For the next 5 years or so, Dennis and I spent probably 20 hours a week, with Bob Monroe as our personal trainer, teaching us about the larger reality system and how to go out of body. And both of us entered this with the idea that we had no idea whether this was actually real or not, but we were going to find out. It was an experiment for us to find out. And it took us some time before we got to the point where we decided that our experiences were indeed real, to a point that a scientist would have to accept them, which means the statistics of the data we were getting was 1 in a million, that we could get it by accident or by luck. And even that was only an intellectual thing. At a deeper level, it came home when Dennis and I did an out-of-body trip together, reported independently of each other, not hearing each other. The 2 tapes were gone, and then they ran the tapes with Dennis and I listening, and there we were having conversations, seeing the same things, and that hit me like a ton of bricks. That was the point where it was, this is real. And then it was like, oh my God, this is real. And I kind of went around in a fog for a week in that state of mind, and then eventually I said, well, okay, it's real now. What are you going to do about it? What are you going to do with it? So I decided to study it. Now, because my background starts then in the kind of the metaphysics part with out of body, sometimes I kind of get associated that way as this is an out of body thing. It's not really an out of body thing. This is more about the larger reality, the point, the purpose of existence. Out of body is just one set of experiences. It's one of many set of experiences, and you do not have to ever go out of body or do anything paranormal to succeed in what you're doing in this reality frame. And we'll get into more of that. It's just there as something you can do with it because you're consciousness, and this reality is fundamentally consciousness. So it's available to you, but it's in no way necessary to your growth. Same with any of the paranormal things. So that's, sometimes people get the idea, well, I can't do that, therefore I failed and I can't go on with my path. Often, those who are frustrated about not being able to do things like out-of-body or remote view, not only do they feel like they can't do it, but it's their drive to do it is what keeps them from being able to do it. It's much better to just work on yourself, work on becoming love, work on growing up. Forget about the other stuff. And when you're ready, the other stuff just comes by itself. You don't have to pursue it. It will come to you if you're interested. Now, if you're not interested, it doesn't have to ever come to you, and it won't slow you down any. But if you are, it'll come more naturally. If you try to force it first, that's a lot more frustrating way to go. One statement I like to make is that you don't have to get out of your body. Your mind, your consciousness is already out of your body. All you have to do is get into your consciousness. Okay. We'll talk more about that later. First, we're going to talk about the physics, then we're going to talk about the metaphysics. Okay, what's the difference between a big toe and a little toe? Now, I guess all of you know that toe is theory of everything. It was a term coined by Einstein when he was working on unified field theory. So what's the difference between a big toe and a little toe? Well, a little toe has to derive objective science, objective physics. A big toe has to derive a little toe plus subjective experience. Okay, the little toe has to derive consciousness, spirituality, theology, all those things, because that's all part of our life. Subjective experience is the bigger part of the meaning in our lives. The objective experience is mostly about the stuff, the articles, the things we do. The subjective experience is more about who we are, our values, the people in our lives, our relationships. The important stuff is really subjective. The objective stuff has less uncertainty. Therefore, it's easier to study, get a hold of it. Okay, science has found no little toe yet, though not for lack of trying. There's been lots of efforts. Einstein's unified field theory, we mentioned that one. That was the first. The latest, I would say, that's had any success at all is probably string theory, and it's had just a little success in trying to become a toe, but it has many, many problems. It's not that successful yet. So we want to derive the meaning, the point, the purpose of things, people, interactions, relationships. A little toe has to do better, more comprehensive and complete physics, and better, more comprehensive and complete metaphysics. Okay, now many scientists believe that finding a little toe is impossible. They've given up on the little toe. Einstein couldn't do it, then who am I to try? That sort of thing. But how much harder then would it be to find a big toe, which is a little toe plus all the rest? Impossible squared, impossible to the 10th power, so impossible that it's not even worth considering? Many people have that opinion. It's just never going to happen. Metaphysics and physics becoming one together under one understanding. But it has happened. Now we're going to start a little with the science. Many of you have seen this before. That's the double slit experiment. This is probably the most repeated experiment ever done. This experiment's been done by literally, hundreds of different places by probably tens of hundreds of different people. Very well done, and they always get the same answer. But they keep doing it anyway because nobody really believes it until they do it themselves. So this is a very well-worn experiment. Okay. What we have here is a barrier with two holes in it. That's called the double slit. And we had known for a long time, for decades, that if you send a coherent light into this double slit, some of the light will go through this hole, some of the light goes through that hole, and each hole becomes like a new source of light, and those two sources will interfere with each other. And when they do, you notice that this path is shorter than that path. That has a little longer distance to go, right? When the difference of length between those two paths is some integral number of wavelengths. Okay, now a wavelength is like one of these things. It goes from here to up to down and back to where it started again. It's a wiggle, it's a wavelength. So when you have an integral number of wavelengths difference in that path, then they become in phase. So what happens is this picture. The humps come at the same time, the dips come at the same time. That's called superposition. They add, you get something that's twice as big. Okay, they add together. Now, what happens if the difference between these two paths is some odd integer of half wavelengths? Like the difference between the two paths is 1/2 wavelengths, 3/2 wavelengths, 5/2 wavelengths, and so on. What you're going to get is this picture. Now they're exactly 1/2 wavelength out of phase, which means one's peak comes at another's dip, and this peak comes at that dip, and so on. Now they're just out of phase. And what you get when they're out of phase is nothing. They cancel each other. That's what happens in these little spots here where there's no light. You see, between all these spots of light, that's where they canceled each other out. And all these little spots where there are light, that's where they superimpose together. Okay, that's a diffraction pattern. Simple physics back in the late 1800s. Okay, well known. Well, let me show you this. I don't know if you can see this. Can you see this little line back here? That's sort of a representation of the number of the amount of light that was collected at each one of these. This spot, of course, gets the most because it's right behind this slit, so it's an equal distance from both of those slits to that. So it's a big light. And there's a little less light here and a little less light here. As it spreads out, it gets dimmer and dimmer. Diffraction pattern. Now, everybody was pleased with that until Einstein, some 2 or 3 decades after this was well known, did some experiments that showed that light came in discrete chunks of momentum. Well, that sounds like a particle. Well, it is a particle. Call it a photon. Now light's a particle. Well, they said, if light's a particle, how do we get this diffraction pattern? Because we know particles act like this, right? Light goes through the slit. If it's a particle, it has to travel in a straight line unless acted on by an exterior force. It's Newton's second law or something like that, okay? So we get a straight line and a spot of light, straight line, a spot of light if it's a particle. But yet light was doing this. Big mystery. So they wanted to solve this mystery by doing this experiment and firing one photon at a time toward those 2 slits, just one particle at a time, instead of billions of particles at a time. And when they did that, they fired one particle at a time at these slits, and of course they had to keep doing one particle, another part, so they sent really tens of thousands of particles all together, but just one at a time. And when they did that, they expected they would get this, because after all, that's a particle. What they got was this. And I should also tell you that this experiment doesn't just work with light. It works as well with electrons, hydrogen atoms, and the biggest thing they've thrown through there is a buckyball. That's a 60 carbon atoms tied together in a shape like a soccer ball. It's huge and massive, compared to a photon. And they send buckyballs through there and they do the same thing. When you send a buckyball at this, it turns into a diffraction pattern. Okay, so it's not just magic little photons that are massless particles that always go the speed of light, so they're kind of different, but anything will work. Okay, in fact, you could throw a toaster oven at it and it would work if you could scale the experiment enough so that the uncertainty of the trajectory of the toaster oven was like the uncertainty of these photons and buckyballs, you see. So it's impractical to do the experiment for things that are too big. Doing the buckyballs was hard enough because it was so big. They had the physical experiment gets more and more difficult the bigger the particle gets. But it's a general principle that if you could throw a toaster oven at that, and if you could do the experiment, the toaster oven, there'd be a bunch of toaster ovens there, and a few toaster ovens there, and a few toaster ovens there, and none of them in between. Because the toaster ovens would go through both slits, interfere with themselves, and then recreate over on the other side. Strange, isn't it? That was the problem. Now they thought, well, there's something funny going on at this slit. Something about going through this slit that we don't know about, because we're sending one particle and we're getting a distribution that's a diffraction pattern, and that's just not right. It doesn't make sense. So let's measure what's going on at the slit. And these little red spots are detectors. They're just going to detect whenever a photon or an electron or a buckyball goes through the slit. They're just going to send a little signal and say, okay, one went through this slit. And when they detected what slit the particles went through, they got this result: particles. Turn the detectors off. Oh, they got this diffraction pattern. Well, that's clear then. It's the detection's doing something to it. Well, that didn't turn out to be true, because they could leave the detectors on detecting and just not collect any data, or collect the data and then erase it, and they got the diffraction pattern. You see? So now everybody's head was being scratched, right? This doesn't make sense. And that's why this double slit experiment is such a big deal, and that's why everybody, does it all over the world, because what it tells you is that our reality is not objective. We don't live in a Newtonian objective reality. Our causality is not objective. Okay, the next slide will tell us how they fixed the problem. They fixed the problem by saying that a particle is not a particle. There are no really massive particles out there that we can't see them. They're just probability distributions. And I don't mean by that let's say that's a probability distribution in location of the particle. And it doesn't mean that it's out there somewhere as a particle and we just don't know where, and that's the probability distribution. It means that there is no particle. The particle itself is just represented by a probability distribution. Okay, now the reason that worked and got them out of the trouble is because part of the probability could go through that slit, and part of the probability could go through that slit, and the probability could combine with itself like a wave, and it could make a diffraction pattern. And then here, this little curvy wave that you can't see anymore that goes here, you can see it down here with the two humps, that became the probability distribution of the results. Okay. And that solved their problem because now they could explain the experiment, but it created a problem because now they said that particles aren't particles, they're probability distributions. So that was the solution. And the way the language went, they said when you made the measurement, you collapsed the wave function. This was a probability wave, and it had a wave function. It was this mathematical representation. When you made the measurement, here at these detectors, you made the measurement, you collapsed the wave function to a physical particle. Before that, it was just probability. Once you get a physical particle, then the physical particle has to act like a physical particle from then on. Now, some people said, well, I just can't believe that, measuring that particle creates the particle out of probability. There's something else going on there. And they thought, well, maybe it's when you measure it, you interfere with it. It's somehow that measurement process interferes with that particle and changes it somehow. But of course, like I say, they left the detectors on, detecting. They just didn't collect the data, and they got the diffraction pattern. So that theory went out the window. That couldn't be the true, but because that was the only thing they had, a lot of people clung to that anyway and believed it was true because they wanted it to be true because that get them back into an objective reality. But it's not true. It's true that when you make a measurement, you get a particle, but it's not making the measurement. If you read this in the literature, you'll hear people talk about the measurement problem. The measurement problem is that it takes a measurement to make a particle out of probability, and that's too weird for people to accept. That's the measurement problem in physics. But it's not true that a measurement creates the problem. You also will hear that consciousness creates the particle. It's the conscious observer. It's the act of consciousness observing the particle that makes it collapse its wave function down to a particle. That's not true either, although it does take a consciousness to make a measurement. So they're related. What it is it's about the information. If the information exists in this reality to show that it was a particle, in other words, a particle went through the slit, then it has to act like a particle. If there is no information in this reality to determine that it's a particle, then it acts like a wave. So the key thing is information. Okay? Well, this is a reality is based on information. That's at the core of our reality, and that's what this says. Okay, physicists are supposed to generate theory to explain experiments, not ignore experiments to maintain theory that doesn't work. That may seem odd, but it's happened many times before. For example, the Greeks, some 200 years before it was commonly understood that the earth was not flat, they had already logically determined that the earth was a sphere. They did it in a couple of ways. One, they knew that the phases of the moon were the shadow of the earth upon the moon. And what does that shadow look like? A curve, like a shadow of a sphere. That's hard to get that from something flat. Also, they watched ships as they went out from land. And what did they do? First, you can see the whole ship, then you can see the middle of the ship, then you can see the top of the ship, then you can just see the flag, flying up above the mast. The ship's sinking in view. Well, the only way to explain that is that it's going around. You see, it's dropping down the other side of the circle. So they had that. They had some other astronomical things that they said the earth must be a sphere. 200 years go by, and that was widely disseminated, and everybody agreed with them. Yeah, sure seems that way. It can't possibly be true. Why? It doesn't make sense. If the earth was a sphere, all the water would drain out of the oceans and fall off, and all the people and things that lived on the other side would all fall off. Couldn't possibly, it was just obvious that wasn't true, because as they sailed, they didn't slip down the sides and fall off of the sphere. Well, you see, there was a piece of their information that was missing called gravity, right? But to them, it was a ridiculous idea. So it took 200 years later before that became well known. Today, there's a strong belief that our reality must be objective. We have not gotten over Newton yet. We still have that belief system. Okay, we're about 90 years past the time when this experiment was performed, and heads are, for the most part, still firmly in the sand because, well, it just doesn't make sense. There must be some other explanation. Physicists today simply call it intractable, weird, impossible science. They search in vain for an interpretation of the experimental facts that will make sense within their belief of an objective reality. And there are now in the stable of interpretations of this experiment, some 20 or 30 interpretations of this, trying to make it fit an objective reality. Matter of fact, the original explanation of this done by Bohr and Heisenberg, two of the German scientists that discovered quantum mechanics, discovered this thing. They now call that the Copenhagen interpretation. But Bohr and Heisenberg didn't call it that. They just called it Copenhagen statement. It was a bunch of physicists came together and just made a statement of what the facts were. Here's what we found. Well, they didn't find objective reality, and that was in their statement, but they've been demoted to just one of a bunch of interpretations, you see. Okay, so physicists in general have they know it's there, they do the experiment, and then they forget about it because there's no future in it. Results of this experiment were so dramatic and clear, they were so unexpected, they were so contrary to belief that it prompted the brilliant men who understood this experiment to say some very unusual things that were said by Einstein. Einstein primarily did relativity, but he also worked on quantum mechanics. But it lets you know, I'm going to have a bunch of these quotes, it lets you know where these people were. Now this is back in the 1920s, okay? The Copenhagen statement was put together like 1924 to maybe 26. It was in that range. So we're talking like 87, almost 90 years ago. Okay? Albert Einstein, if we think of the field being removed, there's no space which remains, since space doesn't have an independent existence. Reality is merely an illusion. It's clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. It's a function of our conceptual scheme. Space is a function of mind. And then at the end, Albert Einstein, after he worked the last 25 to 30 years of his life trying to come up with a unified field theory little toe, and didn't succeed, a letter to one of his co-workers. One has to find the possibility to avoid the continuum together with space and time altogether, but I have not the slightest idea what kind of elementary concepts could be used in such a theory. You see, they knew that the time of Newton was finally over, but they just really didn't know what to do with it. Because just knowing the fact from an experiment isn't enough. You have to have an explanation. You have to be able to relate it to the world before it's useful. Okay, the next one is Wigner. It will remain remarkable in whatever way our future concepts may develop that every study of the external world led to the scientific conclusion that the content of consciousness is the ultimate universal reality. Max Planck. Science cannot solve the ultimate mystery of nature because in the last analysis, we ourselves are part of the mystery we're trying to solve. See, that's like Einstein saying the space of physics is a function of our conceptual scheme. What's out here, our reality, is somehow entangled with what's in here, is what they're saying. All right. Okay, now we're going to have one from Niels Bohr. Bohr said, the common sense view of the world in terms of objects that really exist out there, independently of our observations, totally collapses in the face of the quantum factor. He meant in the face of quantum mechanics, new knowledge that they just had. Also from Niels Bohr, if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. Okay? So these are all these people I just quoted were all Nobel Prize winners, all of them. They were all the best of the best, probably the best scientists, the most creative and out-of-the-box thinking scientists that we've seen for 100 years. So That's what they thought at the time. Contemporary scientific big picture, we have about 1992, okay? That's 60 years after the double slit experiment. We have Edward Fredkin, who is still a working, well thought of physicist. Strong reputation. He was a professor at MIT, then went to Boston University, and then I think to Carnegie Mellon because he was more into computer works, and Carnegie Mellon is center of excellence for computer work. So Fredkin is a pretty solid source. He says reality is essentially informational. It's just informational. That it's a simulation. That our reality, we're living in a simulation. That reality is information. It's digital. Time is digital. When I say digital, I mean it's broken into discrete chunks. It's quantum, broken into chunks. Okay, that's the nature of reality. Okay, that was reported in a physics forum back in 1992. He didn't just say that because it came to him in a dream. He did a lot of science and he had a lot of equations to support that. Nick Bostrom, he's a head of a department now at Oxford. Are you living in a computer simulation? He has degrees in both physics and philosophy. His answer to that was, it's very likely that we're all living in a simulation. Brian Whitworth published his in refereed journals as well. He took the data points, what I call, the data, the facts that we know, that physics has discovered by experiment. Here are the facts. And he says, which theory best fits the facts and has the fewest problems and answers the most facts, or explains the most facts? The reality is virtual and computed, or reality is objective. And he didn't have a dog in the fight either way. He was a computer scientist, and he wanted to know. So he did the research, and then he published it, and his last paragraph in his paper said, physicists, wake up. A virtual reality is a much better model. It fits the data better than the old Newtonian objective reality. So now we're seeing a fair amount of movement out there. Digital physics now is all over the world. There's a lot of digital physicists who are agreeing with Fredkin. So we're kind of moving in that direction. Of course, breakthrough, always comes from the fringe. It comes from out on the edge. Breakthrough never comes from the middle. The middle isn't there to make breakthroughs. The middle is there to provide resources, infrastructure, and support. Because if it needed a breakthrough, then it needs something that nobody knows. Breakthrough is sudden new knowledge. Well, sudden new knowledge doesn't just erupt up out of the middle. It comes from the outer edges. It has to exist out on the fringe for a while before it slowly makes its way to acceptance into the center. But now let's get into, what does this have to do with consciousness? We're going to slip from physics into metaphysics. Consciousness is the fundamental reality. The larger consciousness system is a digital information system. Okay, digital information system. Now you can think of that practically by thinking about what is your reality. What's the reality you're in right now? How do you get this reality? It's just data. It's not only just data, it's digital data. You have photons that hit your retina. That retina produces an electric signal. That electric signal is a discrete signal. It's data. That electric signal creates patterns of neurons, fires neurons off, and it ends up with patterns of neurons, okay, in your central nervous system. That's just data. Neurons are discrete particles. So what is this reality? It's, 5 senses, right? Sight, hearing, touch, it's all that, smell, and it's all just data. If that data could be impressed on your brain, if you put on a helmet and it would take all that same data and press that on your brain, you'd see this reality. That's how you interpret the data. All those little patterns of neurons and electrical signals look like this, sound like this. That's how you interpret them. Okay? So now we take one step removed. This is a virtual reality. You don't have a physical body or a physical brain, either one. You're just consciousness. And you're getting the data stream that it has all that data. And you're interpreting it according to the rule set that defines this virtual reality. Virtual realities have to have rule sets. You know, what's the physics? How does the virtual reality work? So your consciousness, you're getting the data, and you have to define it in terms of this rule set. And you're thinking, well, that'd be hard to learn, that rule set. You know, how would you take all those little impulses and neurons and, you know, teach yourself that it's this? Well, that's what we do in this reality when we're born, when we're infants. Okay, that's what we're doing when we're lying there, you know, making gurgling noises and an arm shoots over and we don't know that's our arm. You know, just something was there. It's probably 3 or 4 weeks go by before the baby even knows that that arm's attached to him and that he has some will to move it. So he's learning, you see, how to interpret this reality. Somebody comes up and speaks to him. His ears give him digital data. He learns to interpret that data as mom or dad or baby sister. So that's how we learn to interpret those electrical pulses and those patterns of neurons to be this reality. Okay, and what's that baby doing? He's interacting within the rule set of a virtual reality. Okay, so consciousness is just information. Our awareness here, this reality, is just information. Now, at the most fundamental level, information is bits. So if you take information and break it down to the smallest particle, it's a bit, smallest piece of information. Bits, in the most simple configuration of bits, are binary, ones and zeros, up, down, left, right, hot, cold, good, not good, whatever, just a pair of two different states. Okay, now information is non-physical, information is subjective. Okay, consciousness is non-physical and subjective. Okay, what that means is that every one of us gets our own personal data stream. Okay, this is a multiplayer game, so we're all in here together. We interact just like in The Sims or the World of Warcraft. It's a multiplayer game, and you get this data stream. You have other players. Some of the players are maybe computer players. Some of the other people that are in the game, and it's your own personal data stream. You live in your own personal reality. Okay, we think there's a big reality out there besides that, but it's just, your reality is just what you perceive. You take out all those senses, eliminate your 5 senses, and where's your reality? It's gone. No touch, no sight, no sound, no smell. Where's your reality? You're in the void. There is none. You see, you have your own individual data. You create your own reality. You are a reality. Your view of reality is yours. It's personal. Consciousness is subjective. Our interpretation of the data is subjective. Okay, so when we get this data stream, and we've got data now, okay, we've learned how to interpret it, but that interpretation is subjective. It's our own interpretation. It's personal. You may find it unusual that information is non-physical, but if you think about it a minute, of course information's non-physical. Look at a book. Well, a book's a physical thing, but a book, that's the media. Right? The paper's the media. The ink in the book are the symbols, the code symbols. The ink is physical and the paper is physical, but that's not the information. Information is the meaning, the content, the message. The media and the code symbols aren't information. They're just ways of recording and transmitting information. But the information, to get the meaning, you have to have a consciousness. You can take a picture of that book page, but the camera doesn't get any meaning. It just captured an image of the book and the code signals. It takes a consciousness to find the meaning, so to get the information. So information's not media, information's not code symbols, information is content. It requires a consciousness. It's non-physical. You can't take meaning and weigh it. It doesn't have volume, it takes up no space. It's not physical. Okay, information systems. I'm going to talk a little bit about evolution. I'm trying to bring together this whole idea of consciousness, virtual reality, and the fact that our reality is probabilistic and statistical. Information in a digital system is represented by organized bits, right? Information systems have entropy. Now, entropy is a physics word, comes out of thermodynamics, and basically it's a simple concept. It's just a measure of disorder. So you have maximum entropy when everything is just random. Okay, no structure, no order, just random. High entropy. You start taking those pieces, putting them together in special ways, and you can actually create content. You can create meaning. Maybe those things were a bunch of alphabet letters, and they're just thrown around random, no meaning. Put them in the right order, you spell words. Maybe they were just patterns. You could have a pattern that would go up, 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 down, down, up, 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 down, down, in a pattern. There's information there because what's the next three? Up, 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 because they just went down, down, right? So that has information. It tells you what the next thing's going to be. So it doesn't take just written words for information. Information can be in patterns. So a large, complex information system, okay, now this is going to be a self-changing information system, obviously. If it's going to evolve, it has to be able to change itself. To be self-changing, it also, at least some rudimentary way, has to be self-aware. It has to be able to know what it's changing itself to is better or worse than what it had before. So a self-changing system with a purpose to evolve, be more successful, it's required to do that in order to survive. It has to evolve to survive. It can de-evolve, which means it throws everything back out on the floor in a random motion. There's no content there, and then it's nothing. It doesn't exist as a system anymore. There's no information. It's just noise, just randomness. So it's by evolving and lowering its entropy. Lowering entropy is more order. Raising entropy is more disorder. Okay, so consciousness is a self-aware modifying system evolving toward lower entropy states, because that's what systems do. Self-changing systems evolve toward more profitable states. For an information system, that profitable state evolves toward more content, okay, more order. Here would probably be a good place to make a comment about free will. Okay, free will is important here because we're talking about decisions, right? We're talking about evolution. We're talking about changing. Okay, so free will is not a magic thing. There are many people have a very strange view of free will that ends up with all sorts of problems with it. But it's their concept of free will is the problem, not free will itself. Free will is a simple thing. You have, at any particular time, in any particular circumstance, you have certain choices that you can make, certain choices that you're aware of. Now, the choices that you could possibly make is maybe a set this big. There's maybe 100 choices you could possibly make, but maybe there's only 20 that you're really even aware of that you could make. It's just that 20 that you're aware of that you could make makes up a thing I call your decision space. That's all the decisions, all the choices that you can make are that 20. Okay, that's your decision space. Now, you have free will to choose one of those 20. That's what free will is. It's the freedom to make a choice of the choices that are in your decision space. Now, the more your reality grows, the bigger your decision space gets. So decision space goes up and down. You get thrown in jail, and your decision space just got smaller because there's a lot of things you can't do now that you used to be able to do. So decision space goes up and down. People who become suicidal, their main problem is the size of their decision space. It narrows way down. There's nothing in their reality anymore except that one thing that upsets them. It's that one thing that's so horrible. All the rest of the things, all the potential, all the nice things that could happen, all of the other possibilities that could happen in their life don't exist. Their decision space is just down. It's so narrow that they can only see that awful, awful event that they can't stand to live with. That's the problem. Okay, they have a very small reality. So the size of your decision space is a measure of the size of your reality. So not only do all have independent realities, all have subjective individual realities, but they're all different sizes. Some people have big realities, some people have little realities. People that travel a lot tend to have bigger realities than people that never leave home. See, it's just, that's what free will is, okay? So you only need to have enough freedom to choose within your decision space. That's free will. Some attributes of consciousness. Consciousness is a real, finite, large, complex, self-modifying information system, and it has to evolve or de-evolve. There is a third choice, which would be stay the same. Never evolve, never de-evolve, just stay the same, but that's unstable. Any large, complex system eventually is going to move one way or the other. Stasis is not a stable condition. If you start evolving, that lets you evolve more, which then helps you evolve more, same with de-evolving. If you start to de-evolve, that makes it easier to de-evolve more, so you tend to move in the direction that you're moving, to move more in the direction that you're moving. So being the same, staying the same is not practical for a long period of time. Now here's one that's a major statement here, but I can hopefully explain it to you. Love is the nature of a low entropy consciousness. Now I'm going to connect entropy with love. Sounds like something a physicist would do, doesn't it? Connect entropy with love, but we're talking about an information system. Now in this digital information system, the point of it is interaction. Okay, the point is trading data, evolving itself, more content. All right, so it's about exchange and data. And basically the outline of the larger conscious system is sort of like the outline of the Darwinian evolution. You have a consciousness system and it's a very crude thing. It just sort of knows off on or yes, no, or 1, 0, and then it can do more of those, and pretty soon it builds up enough to have memory and enough to compute and that sort of thing. So it's something that evolves. The conscious system is just a normal system, just a system that is evolving. So it, like the biological systems, is looking for lower entropy. It does that by having more order, more complexity, so it breaks into pieces. You had a one-celled thing over here in Darwin, and it found it more survivable and better for procreation if it had 2 cells or 3 cells. And then it found it better if the cells specialized and it had the locomotion part and the eating part and the digestion part. And it kept getting more and more complicated, because the more complicated it got, the more adaptable it got, you see. So in a consciousness system, you have a couple of 1, 0s, a couple of states that it's aware of, and then more states, and pretty soon it breaks into pieces. The pieces interact with each other, because why? That's more complexity, right? If you have one thing interacting with itself, it gets boring after a while. If you have a whole lot of things interacting with free will with each other, now you have chaos. You got a lot of possibilities. You got a rich soup of things that could happen. Suddenly the complexity goes way up. The possibility of creating information out of that chaos goes way up than just one thing interacting with itself. But of course this is one thing, right? It's one thing that has subdivided pieces and let the pieces interact with free will. So anyway, I have love connected with low entropy. So now we have these pieces of consciousness. They're interacting with each other, and I will try to convince you that the most optimal interaction, the most optimal relationship and sharing is one of love. The opposite of that is fear. The opposite of love is fear, and fear is a very, I call it not optimal relationship, right? Fear is a disintegrating thing. Fear tears apart. Fear pushes away. Fear is not a building, constructing thing. And the way I like to describe this is imagine a group of say 10,000 beings. We're going to do an experiment. And where these 10,000 beings are all going to be caring beings. They all care for each other. They all help each other. It's all about other, not about them. It's not about self. They all work together. And we're going to take these beings and we're going to put them in an environment. We're going to give them a certain amount of resources, a certain amount of time. We're going to come back, 50 years later and see what they've done. And then we're going to take the second group. That's the fear group. Now, all these people are only in it for themselves. It's what about me? They're full of fear. They want to get whatever they can get, and then they have to keep it from somebody else taking it away from them. It's all about fear. How much can I get for me, and how do I keep it? Well, then let's take 10,000 of those and give them the exact same number of resources and the exact same length of time and let them go. And then let's look at them and say, 10 years or 100 years later, what do you expect you'll find? Well, in the one group that was very cooperative, they will probably have optimized their situation with their resources and within the space they have, because it's all about other. Like in the old days when somebody's barn burns down, all the neighbors get around and help them build it up again. It's that sort of thing. Somebody comes up with a better idea, they share it. In the other world, where fear, somebody's barn burns down, well, it's probably burned down by their neighbor, so that they would take some of that produce off the market, right? Now their prices can go up, or some sort of thing like that. It's better for them if their neighbor's barn burns down. Who's going to help him build it? Nobody. Who has time? What's in it for me? You see? What happens in that reality? Well, what happens is that you probably coalesce into a few power centers, each of which dominate an area, and then those various areas fight with each other to try to get each other's stuff. That sounds like the world we live in, doesn't it? Yeah. So that's the difference. So can you see that in a sharing, caring environment, basically in an environment based on love, you have the lower entropy. Things are more ordered. Things are more optimized. Things are more structured. In that fear environment, if you get something and build it up, then the other people are going to try to figure out how to steal that from you, how to take it away from you, how to tear you down. If you've got a nice car, then maybe they'll just shoot you and take your car, you see. That's not constructive. That's not building it up. See the difference? That's how I can relate love with low entropy. So the love is the nature of a low entropy consciousness. So now what if the consciousness system is evolving, right? It's evolving to lower entropy. It's evolving toward love. So becoming love is what it's all about. That's what the system is doing. That's its thing. And it can either do that or it can de-evolve and eventually turn into nothing. And that fear state is obviously a state that's pretty de-evolved. And it's tearing itself apart. That fear state is a hard one to turn around. It just keeps driving itself further and further down in that hole. Okay? So that's how we make that connection. Now, I say individual consciousness evolves toward lower entropy. I also say the same thing. An equivalent statement is that it evolves toward higher quality of consciousness, or you might want to say it evolves toward being more spiritual. We'll equate the growing toward love and spiritual growth. So it's just different phrases, different metaphors that suit different people. I tend to use the lower entropy, higher quality, but it's equivalent to more spiritual. Attributes of consciousness. One, it has to have input. Right? It has to be able to take in information. That's called experience. It has to have memory. If it didn't have a memory, every experience would be its first. So it needs memory in order to be able to serve its purpose, which is to evolve. You can't evolve if you don't know where you've been and where you've just gone, and is it better or is it worse, right? And for that, you need to have a purpose. The purpose lets you determine what's better and what's worse. And you have to be self-modifying, otherwise you can never evolve. You're just always there if you can't be self-modifying. So those are the things that create a consciousness. Well, look at those things. There's two things that should stand out about them. Input, memory, processing. Sounds like a computer, doesn't it? That's natural to a data system. Purpose, well, see, there's one where our computers kind of aren't so good. They don't have much of a purpose. Well, they may have some purpose. You throw in a CD and it automatically gets the right software and loads it up and begins to play it. So it does some of that stuff. It has some little pieces of purpose, but we're talking about a motivating purpose at a deep level. And self-modifying. Now, our computers aren't very good at that yet, self-modifying. But at least the first three, input, memory, and processing, sound pretty digital. And what else does this remind you of? Life. Anything that's alive. This is what it does. It has experience. It has memory, even if that memory is cellular. It doesn't have to be intellectual memory. It can be cellular memory in DNA. It has processing, has purpose, survival, procreation. The processing is required to see, is this better or is this worse? And it has to be self-modifying. Otherwise, it could never change. It evolves. It's self-modifying. It finds that this is better. Well, let's do more of that. And it does that through evolution, not through an intellect. I mean, I say it like it's an intellect. That's better. Let's do more of that. But what's really happening, that's better, so that survives. And what isn't better doesn't. See, so it's not an intellectual process. Evolution just happens. Summary. Consciousness is best modeled as a superset, a self-modifying digital information system capable of computing virtual realities. It lowers the entropy of the system by organizing its bits at its disposable and more profitable configuration. Content creation and reorganization opportunities are generated by using conscious intent to apply free will to choice of incoming experience data, and feedback of the results of previous choice allow us to modify future choice. That's called learning, growth. Okay, so that's kind of where we got so far. Now, this next slide, I'm going to try to explain where it is that we come from. What are we in this? How do we relate to this model that I'm building up for you? Well, because experience is the generator of input. That's where the input data comes from, is experience, right? Then consciousness facilitates its own evolution by creating many smaller units. Remember, the one cell breaks into many cells so that they can interact, because that creates experience. Experience creates the input. Input is what it takes for you to evolve, to grow, become love, lower your entropy. You lower your entropy, and you're a part of the system, so the system gets its entropy lowered too. Your success is its success. You are part of its strategy for survival. You're part of its strategy for its own evolution. Okay, so that's where we come from. That then defines things like morality, purpose of your life and your existence. Your purpose is to lower your entropy, raise the quality of your consciousness, become love, spiritual growth. Why is that your purpose? Because that's the way the system of which you are part is evolving, is surviving. It's a larger consciousness system, the one, right, of which we are all a piece. Okay, now that defines morality. What's good? What's good is what helps lower the entropy and improve the quality of the system. What's bad? What's bad is what disimproves the quality of the system. Okay, so now we have morality defined here. So we get a lot of information out of these assumptions. Okay, so that's what we're doing here, and that's kind of our purpose. Now, what about physical reality? What's this? Why are we in this virtual reality? What's the point of this? In order to produce experience, right? We're here to have experience. So our experience, we can make choices with our free will, and we can grow up, become love. In order to have a meaningful experience, that experience has to have a context. Okay? The way you have context, it has to have purpose, direction. Otherwise, there's no, if your experiences are just random, you have a whole series of random experiences, you can't make anything of that. It doesn't take you anywhere. There's very little growth potential in it, other than you just live in a very weird place because you have all these random experiences and nothing makes sense. None of it's connected. So you need a place where your experience is connected, and you connect things by constraints, rules. These are the rules in our rule set, and this is the way interactions have to occur. And we can only occur according to this rule set. Okay, and this is a multiplayer game. We have to interact with each other. Okay, now what are these bodies? This brain, what part do they play? Well, they are the constraints of our rule set. Okay, they're the constraints of our rule set. Now, where do they come from? Well, where does the rule set come from? In traditional physics, where they believe that the world is objective, they start this universe with a big bang. When there's a big bang, they say that in the beginning, there was a little tiny spot of a lot of energy. And that made it very hot and a lot of pressure, and it expands. And when it expands, it cooled. And when it cooled, gravity coalesced it into pieces, and those pieces became stars, and stars had smaller pieces that became planets, and so on. That's how the universe is derived in traditional physics, called the Big Bang theory. Okay? Well, this is how this rule set came about. It's what I call the Big Digital Bang, or the Big Bang simulation. Okay, so now we're in a computer, we're in a digital consciousness system, and it's evolving a virtual reality. And how does it do that? It doesn't program it. You know, World of Warcraft is programmed. All those rules are programmed in. Our rule set evolves. So you have this computer, and in this computer simulation, you have this little ball of energy, and it's tightly packed, and there's lots of pressure, and then you let it go, and when it goes, it expands, it coalesces into suns and planets, and then you have this planet that, you know, somehow gets some amino acids together and a little bit of electricity, and it gets a cell, and the cells divide, and then the creatures learn to get out of the water and walk on land, and here we are. You see? So all of that's just in the simulation. And we've got these bodies and cells and organs, and all of this stuff just evolved that way from evolution, from that one little cell, and all evolved. So here we are. These then, our bodies, our brains that evolved in this big simulation, become our rule set. Those are the constraints in which this game must be played, because those constraints are a reflection of the rule set. And what's the rule set? Science, biology. You know, it's physics. What's the rule set? Gravity. You know, F equals ma. All the things that we've dug out, all the rules we've dug out of existence, that's the rule set. So here we are going to be the Big Bang simulation in this digital computer called consciousness. And consciousness says, I need this thing to be stable if it's going to be useful, so let's try this rule set. So it has a rule set, and it punches the run button, and off it runs and never turns into anything. You know, let's change the rule set a little bit. You know, let's do gravity that's a inverse square law rather than inverse cube law. That didn't work out too well. So we try that, and well, that worked pretty well. So you can see it evolved. The rule set evolved as well. It's a cut and try. Throw away what doesn't work, keep working with what does work. See, it's all just evolution, natural evolution. It's not like somebody sat down at a computer desk and wrote the code for each blade of grass. It's just an evolved natural system. So in this big digital bang, you keep fiddling with the constants and with the rule set until you get a stable situation that you can use. And then here it is. And here we are. And the rule set then, we are a product of what came out of that rule set. What evolved out of that rule set eventually through the single cells to the multi-cells to us is a representation of what you get when you apply those rules, that physics, those constants. So that's what we live in. So now we're in this game and we're getting this data stream. And the data stream, we are restricted in this data stream to abiding by the rule set. That's why we can't jump 20 feet in the air. That's why we can't learn differential equations in 10 minutes, because the rule set doesn't support it. The rule set says these little legs can't jump 10 feet in the air because gravity and, you know, how big the earth is and how much I weigh and how much muscle I have, how my skeleton's built, all those kinds of things. The rule set evolved me this way, and I'm stuck then as those constraints. So I can't jump 20 feet in the air because the rule set says that doesn't work for the way I evolved. So you see, now your brain's the same way. You have a rule set that evolved this, you know, again, it's in a simulation, this simulated brain, it's just data. And the way that brain evolves, you can't learn differential equations in 10 minutes. It's too much, your brain can't do that. You can't get that much information into you that fast. You can't process it that fast, you see? So you're limited by what the rule set says that your brain can do. Now, if you have an accident, let's say you have a stroke, and part of your brain dies. Well, you can't do as much as you used to do because your constraints just increased. The rule set says that if that part of your brain dies, then certain things you can't do. So you see? So our bodies, our brains are just information. It's just data. It's rule set. It's a result of the big digital bang. So here we are, pieces of consciousness involved in a multiplayer game because it gives us structure It gives us rules so that we can interact within a context that's meaningful to us, that lets us grow. It's not just random interaction anymore. We got interaction, we got a real game going here. So if I'm a mean, nasty, using kind of person, and everybody I come in contact to, my thought is, what can I get out of this person? Then you won't like me. I'll be annoying, you see? So I'm creating feedback. You're helping me learn. Okay, it's that sort of thing. So now we have traction. We can actually are in an environment that is stable, it's continuous, it's straight. We don't have things teleporting around. Our time doesn't speed up and slow down. We're just in this nice learning lab where everything works well. It's all continuous, and this is the optimal place for us to learn. And we learn by making choices, and those choices either help lower our entropy or help raise our entropy. And we grow. We pull ourselves up by our bootstraps just by our own desire to become love, to grow up. So that's what it's all about. That's how the system works. So if you had no constraints, if we didn't have this virtual reality, we would just have all this data coming. We wouldn't have any way to fix it. So without the constraints, you get chaos. Evolution is difficult. The rule set that defines our virtual physical reality, physics, provides the constraints. Okay. So if you didn't have this physical reality, it would be like being in a chat room with 1,000 other people, and everybody's voice is synthesized so everyone sounds exactly the same. What kind of traction can you get out of that? Somebody says, "Hi, I'm Joe. I'm a lumberjack," and it could be a 12-year-old girl, in China. You never know. There's nothing you can do with it. There's no traction. It's hard to get feedback from that kind of a situation because nothing sticks. It's all loose. So that's why we need this physical reality. So here's the logical string. Evolution requires free will choice and change through experience. Experience requires interaction and expression of your consciousness quality. Meaningful interaction requires structure and purpose, and learning, entropy reduction, requires structured interaction and feedback. So you see, they all just, one feeds the other, feeds the other. So here we are. This is our reality. Now, as I said before, we are part of its strategy to evolve. Now, I like this analogy, and because I'm a scientist, and those of you who are into mechanical things out there, you'll like this analogy too, and the rest of you, all you right-brain people, you'll hate this analogy. But I don't know if you know how a refrigeration cycle works, but I'll explain it in just a second. You have what's called a working fluid, and that working fluid just gets compressed. It just goes round and round and round. You don't add more unless you have a leak. It just keeps going round and round and round. And what happens is the compressor compresses it and makes it hot. And then it squirts it through a little hole that makes it expand and gets cool. And then it pumps it around again, it gets hot. And then it expands again and it gets cool. And if you want it to be an air conditioner, you hook your heat exchanger up to the cool side. If you want it to be a heater, you hook your heat exchanger up to the hot side. That's called a heat pump. And it just sits there and runs the compressor, and this little fluid just keeps going around and around and around. We're like that. We're in a entropy reduction machine, and we're the working fluid. We go around and around and around, and each time we go around, we're supposed to lose a little entropy. We're supposed to grow up a little, okay? Because we can't do it all in one shot. So we have lots of cycles here. It's only efficient to build over time. You see, it's not efficient to build learning one shot. You got one shot to learn it, you're done. It's not efficient. Learning is a cumulative thing. So we go round and round and round, we're learning and we're growing. So we're the working fluid in a consciousness, evolution, entropy reduction engine. Isn't that sweet? Don't you like that? Okay, we have now derived the larger consciousness system, individuated units of consciousness, that's you and I, and physical reality. So we've shown how all those things seem to be rational, steps in this process. So now we're going to look at virtual reality. Now, virtual reality is relative to the actual reality where the computation's being done, right? So that's how we define virtual reality. You have the actual reality, like the computer that's doing World of Warcraft, and then you have the virtual reality is the thing that's created. So virtual means informational, computed. Past, present, and future. Now here are the mechanics of how it works. You have this virtual reality. Now we've gotten that far, right? We got us, we got the virtual reality, we got the consciousness system. So here's this virtual reality, and here's the mechanics of how the virtual reality works. Things happen here, right? And they happen in the present. We've got three phases, three things going on here. We have the future, we have the present, and we have the past. All the actions in the present, all your choices, all your decision space is just in that thin line that's the present. Okay, before you get to the present, you have the future probable reality. It's just a database. This database is composed of all the possible things that could happen, everything that possibly could happen, and the probability that it will happen. So some things have high probability, some things are really remote, called the future probable database. Okay, now remember, this is a simulation, so it cranks through time, right? A digital simulation, it increases time, 1 delta t, then things happen, and it increases time, 1 more delta t, and things happen. That's how simulations work. It increases, delta t 1 more time, and it just keeps increasing delta t as the simulation marches on. And so you have, in the front of this, you have this probable future reality. That's what's probably going to happen, all the possibilities and all the probability that they actually work. Then you have the present moment. That's where the action, the rubber hits the road and we make our choices. After that, you have the history, which is everything that could have happened and didn't, and everything that could have happened and did. Okay, now what could have happened and did happen is our history thread. That's what you read about in the history books. What could have happened but didn't, that's what I call unactualized history. And what is that? Well, it's just that same database. Everything that could have been and the probability that it might have, well, if it didn't happen, then it becomes history, unactualized history. If it did happen, it becomes actualized history. So there's really, you just start with this one big probable future database, and you actualize some of it, and the rest of it becomes unactualized history as it passes through the middle. So you can think of this big probable future, and it kind of goes down through t equals 0, right here in the present, right? And then it flows on out into the past. Okay, so that's the mechanism by how this is computed. Well, why is it computed that way? Well, the system needs to know what's going to happen next because it has to be prepared for it. It needs to know what the probabilities are because you can learn from the feedback of things. It needs to know what the history was because you can learn from that feedback. This is a learning lab. Okay, so that's the nature of how it works. Now, this database is populated by you. You're in these databases. You're in all three of those databases. But the only one that has free will is in the present. The present you has free will. Okay? The future you is just probability. It's a model of you. Everything that you are here in the present except no free will because you're not making decisions there. You're just part of a database. Then you make your decisions in the present. Then you go into the past, and now it's just a model of you. Everything that is you that is characterized by that past, except it doesn't have free will. You're not making decisions there. This is a database that you can access. In the Hindu theology, it's called the Akashic Records. It's just a database that's available because you are consciousness. You can go to the database. You can go to the future probability database. You can go to the past database. You can go to the actualized database, the unactualized database. And if you don't know what you're doing, you could be in any one of those and not know, one from the other. But it's all available to you for information. And how do you query the database? With your intent. Your intent queries the database. Matter of fact, this database is so nice that you query the intent and you also include in that intent what your output format is. How do you want it output? And you'll get the data output the way you want. It could come out like a movie. You could go into that past database, and it's just like being there. Like you're there, and it's a movie, and you interact with people. You can ask them questions, and they'll react. But they're like, and now you have your free will because you've taken that from the present, you've projected yourself into the past, you have your free will, you can interact, ask questions, but the answers you get will just be the probability models, you see. They don't really have free will, it's just the probability models. And you'll get, if you wish, the most probable answer that person would give you. And it took me a long time to figure that out. I had to do a lot of cycles through this before that became clear that that's the way it worked. But I finally figured it out when I went through the same sequence many times, and you'd always get the same sequence back, because computers are like that. You know, you query a computer with the exact same query, you're going to get the exact same answer. That's just the way they are. And if all these beings down in this past database had free will, it wouldn't be that way. You'd be bouncing around. You'd have different choices, different times. And that was how I figured that one out. But it's just a lot of research you have to do in these databases to figure out how they work. Where do you get precognitive dreams from? Well, it's a probable future database. Those prognostications all come out of the probable future database. Now, they're just probable. They may not happen. You can change the probability with your intent. How do you heal with your mind? You change the probability with your intent of how that illness is going to progress. How does the placebo effect work? It changes the probability of your health based on the information you're given. Okay? So we can modify that probability. That's one of the feedbacks built into the system. So the system is made so we can learn. We have feedback. Okay, what's this thing? It's called the secret and the law of attraction. Yeah, that's real. That's how that works. It doesn't have anything to do with the universe giving you anything. It has to do with that's the nature of consciousness. You can modify the probabilities with your intent. But there's a caution that goes with that. If you're asking the system to work against itself, you will probably get slapped with a very meaningful lesson, because the system wants you to lower your entropy, wants you to reduce your ego, wants you to get rid of your fear. And if you're using this feedback mechanism in the system to aggrandize your ego, to give yourself more money and a better car and all these things for your ego, you're asking the system to work against itself. And you may even get it, but you probably will get something along with it that will help you learn the lesson. So that's be a little aware there, but yes, you can modify that problem. Okay, so now let's talk a little bit about so we kind of have the structure now of the virtual reality, okay, the databases and how it works. When you look at an aura, what you're doing is going in and getting data out of that database. You're going into the database, you're asking your question, what's that person's health body like? What's that person's emotional body like? And you ask these questions, you get the data back out of the database. Okay, so that's where that comes from. It took me a long time to learn that too, because I realized that you can change your output format in this database. And just because somebody else gets, just because somebody else uses red, jagged lines for anger, if you want, you can use, green jagged lines, or you can use exclamation marks, or you can do anything you want. You just tell the database how you want the output, and the database will give you the output that you want. So you see none of these things that we have metaphors for, like our auras. I've seen auras for probably 40 years now. And at first, I gave them independent existence, but then I realized it was just data, as we are just data. It's just information. You query the database, you get the data back. And if you put it in the same format that was in the book that you read about, then you'll get you'll get it back in that same format that was in the book that you read about. It's not necessary. You can change the format. You can have it come out in graphical format if you like. Matter of fact, I like graphical formats a lot because I think in terms of numbers. That you can look at, you can get somebody's, the same information you get in pictures, you can get in graphs, you can get in movies, you can get any way you want. You just specify the output. All right, so now let's talk about the nature of the virtual reality. So what's this virtual reality like What is it, how does it work with us? And then we're going to tie this back into the double slit experiment, and by then I'll just about be done for this quick run through. One of the rules, I guess the main rule here and what we're trying to accomplish is that when something is rendered to you, okay, your consciousness, you've got a data stream. This reality is being rendered to you in data. It has to do at least two things, and it's really just one thing, but I break it in a couple of parts. It has to be consistent with the rule set. You can't jump 20 feet in the air. And it has to be historically consistent. Okay? Historically consistent means that you're not going to go outside tonight and when you step out of the building, you're going to be in Alaska or you're going to be in Texas or someplace other part of the world. When you get into your car, it'll be a different car. All of that would violate the rule set. It would violate the consistency of the history. When the particle comes through the slit and they know it's a particle, it's got to stay a particle. It has to stay consistently. Now it's a particle, it has to act like one, it's got no other choice. Options are all done. It had other options earlier, but once a particle, always a particle, And that kind of historical consistency has to stay. Okay, so one of the things I like to ask, because it's a good one to talk about, is get you an idea that virtual reality really is a lot like these computer games. Virtual reality is virtual reality, and they work a lot like we do. The big difference is that our virtual reality is many orders of magnitude more complicated, and it's evolved. It's not programmed. It evolved this way. We went through that earlier, so that's the main difference. But other than that, they're the same. So I ask the question because it's obvious in World of Warcraft or in The Sims, do the programmers have to program oxygen for their players to breathe? Do those elves and alligator men and the rest of those people, they have to have little oxygen molecules made for them by the programmers to breathe? Well, of course not. That's ridiculous, right? They're not real. They're just virtual. It's the same with us. It's the exact same with us. And there's no need to render any oxygen molecules in this room. Not at all. So why are we all here breathing and not falling over dead from lack of oxygen if you don't render oxygen molecules? Well, see, you're caught in a trap thinking that this is a Newtonian objective reality. You're caught in that thought process. We don't need oxygen to be rendered here. We just need to act as if we had oxygen. And why do we all go on and act as if we had it? Because it's probable. This is a probabilistic statistical system. There's enough plankton in the ocean, there's enough trees in the woods, that the probability is that we'll have oxygen. So we do. We act like it. You get rid of the plankton, you cut down all the trees, and the probability is that we wouldn't have it, and we'd all start gasping and fall over. You see, it's just probability and statistics. So only the effects have to be rendered. It's much easier job computationally just to render effects. Nobody has to render all the underneath causes. Now, does that mean that when you go to sleep at night, all the world disappears? No, the world was never there to begin with. It's all just virtual. You see, it doesn't disappear. It's just no longer being rendered for you. There's other people in the world, and they still see it's being rendered for them. It's not being rendered for you. So you can't make the things you don't like go away just by closing your eyes, because they're still there being rendered for others. So there's a tree in a park, and everybody goes to bed, and then nobody on the street. There's a tree in the park. All just disappear. It's the wrong question. Reality is not objective. It was never there in the first place. It was just data being rendered to individuals and mutual individuals. So you get up the next morning, you open the window, and you look at the park. There's that tree. There's that park. Now it's being rendered to you. You see? It wasn't rendered to you before. Doesn't mean anything goes away. That's just a habit of thinking that this is an objective reality and that stuff actually exists. Remember what Bohr said? He said that if you think that the stuff that's out there is real, then you haven't really understood quantum mechanics yet. It's not. It's just a virtual reality, and it's in your head. All right, another one that I like a lot, you've probably heard me say it if you've listened to the YouTube, but it's fun anyway. If a tree falls in the woods and there's nobody there to hear it, Does it make a sound? And of course, the same thing that we've just been saying, it's all virtual. There is no tree, there's no woods, there's no sound, it's all statistical. So how does that work? Well, the guy walks into the woods and he sees a wobbly tree standing up. So here's this tree and it's not falling over, it's wobbly. Now, why does he see a wobbly tree? Because that's a probable thing for him to see. Could he have seen something else? Sure. There was probably 50 things that would have been not any conflict with those two rules I said. No conflict with the rule set, no conflict with historical consistency, because this was a virgin woods nobody had walked into before. So there was no pictures laying around of that part of the woods or no surveys done. So there's lots of uncertainty there. Where there's lots of uncertainty, there's lots of choice. Okay, so there may have been 50 different things he could have seen. So what happens? You reach in and you grab a random draw out of the probability distribution, comes up a dead tree standing there wobbling around. So that's what he sees. So now he walks out of the woods, comes back 5 years later, and he sees a tree laying on the ground. Why? Because 5 years later, it's probable that that tree would have fallen over. So it gets rendered to him lying on the ground. Did it fall? No. It didn't even exist. Never did exist. It got rendered because it was probable wobbly. It got rendered because it was probable laying down. It's just because you believe in an objective reality that you think it had to fall from one state to the other, because you think it's real and it's out there, and it's not. So see, that's how probability works. Now let's say the guy saw the wobbly tree, he goes out of the woods, and he takes 2 steps out of the woods, he gets eaten by a bear. No. The information's gone. The information's no longer here. He made the measurement, right? He saw the tree, but now the information's just been erased. So let's say right after he gets eaten by a bear, the bear walks off and another guy walks into the woods. Does he see that same tree? Maybe. Probably not, because there's probably a lot of different things it could be, and there's no history that says it has to be a dead tree there, or a wobbly tree standing there. He could walk into that woods and there would be no wobbly tree there. See, it doesn't matter, because that wouldn't violate any consistency. There's no record that violates the consistency of that historical. There's no reason why, by the rule sets, you couldn't have a live tree standing there. So you get a different picture. But now, once he leaves, let's say he's in there and he takes a picture of the woods, and he leaves, and anybody else comes in there, are they going to see the same thing he saw? Yes. Why? Because the measurement's been taken and the information is available. See how we have the same thing as the double slit? Why? Do we see the double, why does the double slit work that way? Because when you take the measurement of what slit goes through and you have that data available, then you get just 2 spots. You don't get a diffraction pattern, because now that would be inconsistent with the history. The history says, I know that a particle went through that slit. Well, then a particle has to go through the slit and you got 2 spots. But if you erase that data before you look at the result, even though you took the data, you throw it away, you burn it up, and then you look at the result, oh, now you get a diffraction pattern. You see, because what matters is whether or not there's an inconsistency in your reality. No inconsistency, no problem. Now this gives the system multiple solutions to any problem. So if you've got if you're making choices or whatever, and you're doing measurements, right? We're making a choice to do something, some measurement. There may be 10 different ways that could come out without any conflict in the system. Still abides by the rule set, historical consistency. So which one of those 10 are you going to get? Well, it could just be because you randomly draw out one and that's the one you get. Or the system may say, well, I think if it came out this one, that would kind of give you a wake-up call. That would really help you in your time of need. That would be something that would be useful to you as far as your growth goes. That's called synchronicity. Things just happen when you need them. Things just are there, just at the time and the place that just is right for you, and it's, we call that synchronicity. So the system is actually trying to help you. And it can do that if you're open to the help. If you're not open to the help, then there's no point. Because if you're not open to the help, why would it bother? It's not going to do you any good. But if you're open to the help and you say, gee, that was really amazing. That, look at this line of incidents that happened to me. I just went to here, to here, to here, and then bingo, there I was. That's hard to believe that was just, random. And it could be random. It could just been luck the way it played out. but it doesn't have to be. You see, there is a possibility that the system can manipulate those things to nudge you. Now, it can't make choices for you, but it can give you opportunities to make good choices, to see things, to look at a bigger picture. That's what it can give you. But you still have to make the choice, do whatever it is you do. So the system is really trying to help you out, if you let it. If you want more help from the system, then put yourself in a position to learn from it, and you'll get it. Put yourself in a position that you won't learn anything no matter what happens, and you won't get any of it. Okay, so that's some good advice. Okay, so uncertainty provides wiggle room within the constraints, okay, of the psi uncertainty in the rule set. So that's how all this relates back to the double slit. You see, the double slit experiment's not just about little things, like physicists will tell you, oh, that's just in the world of the tiny. The reason it works in the world of the tiny is because in the world of the tiny, there's lots of uncertainty. Okay, you got electrons zipping around or a photon running around at the speed of light. Where is it? It's hard to tell, you know. It has this huge uncertainty in its position. Well, there's so much uncertainty in position that the probability of where it might be, you see, can go across both slits. So it can go through probability, can go through both slits. That toaster oven, where it is, has a teeny little, probability of where it is. We know where that is because that's a big thing we can see. So it's such a tiny little uncertainty that it can't do that. You see what I mean? So that's why we think that quantum mechanics only applies to little things. But see the bear in the woods and the tree? Quantum mechanics. The same quantum mechanics that this double slit applies to our everyday life. Our whole reality is like that. It always bothered me when I was in graduate school that quantum mechanics only applied to little things. It's like, why is that? Why do you have a general rule of physics and it only applies to little things? If it's a general rule of physics, it'll apply to things. And it'll apply the same to everything. It's not like, well, here's a rule. Well, are you too big for me to apply to you? Are you a big thing? Sorry, it can't apply to you. That doesn't make sense. Physics generally doesn't work that way. If it's a rule, it's a rule. It applies. And this thing, well, it only applies to little things. What it applies to is things that have uncertainty. Well, we have lots of things in our life that have uncertainty in them, don't they? We probably have more uncertainty than that electron has in its position with a lot of things that we do. And in all those things that are uncertain like that, like what you're going to find when you walk into a woods, a lot of uncertainty there. A lot of things can happen. We live in a probabilistic, statistical reality, and that means that strange things can happen. That means that we can have things like synchronicity. That means we can, take a 2-hour drive in an hour, and somehow we just get home and we don't know how it was. That was impossible, but it happened, Things like that happen, and they can happen as long as they don't violate those rules. So you live in a really squirrely world, and that's the way that is. Speaking of squirrels, let's say that tree that was wobbly had some squirrel nests in it. Okay, let's say some squirrels lived in that woods. So squirrels live in that tree. Now, the guy goes out, gets eaten by a bear, and the next guy comes in. Is he going to see the same thing? Yes. Why? Because it's a multiplayer game, and those squirrels are part of the game. Their consciousness, in their mind, they have that tree mean something to them, that it exists there like that. And you're not going to come in and not find that tree. The tree has already come into this reality through a measurement of squirrel consciousness. Now, squirrel consciousness isn't like people consciousness, so it only has to come into this reality to the extent that a squirrel sees it. To the extent that a human sees it, it's entirely different. See? So there's lots of things that are uncertain. So maybe there's this great big old tree and it's down in your Central Park and it's been there for 200 years. Everything's pretty well known about it. It's always going to be there. It's always going to look the same. The roots are always going to look the same. Lots of people have seen it. Lots of people have taken their pictures next to it. But what about way up at the top where nobody's ever been? Is there a bump up there or not? Well, you go up there and take a look and make a measurement. And there may be just as equal probability that there is one as there's not one. You got a 50-50 chance. You might get one or the other. You see, it's not an objective reality. Consciousness changes the probabilities. That's why things like the law of attraction works. That's why, back in the 1957, I think, Norman Vincent Peale did Power of Positive Thinking. And we all know that works. You've probably read things about the power of prayer, and there's some statistics that say that works. Well, of course it works. That's intent, modifying the probability. Placebo effect, that's intent, modifying the probability. You see, these things work that way. A lot of us use that in day-to-day life. I had one guy tells me, he says, whenever he goes to the grocery store, he never picks up a cart, but all the way to the grocery store, he has this thing that when he walks through the door, there'll be a cart right in the aisle where he wants it. And he says he gets that right about 75% of the time. There's just one sitting there for him. That's because he changes the probability that makes that more likely. Now, he doesn't get it every time because, it's a multiplayer game. Other things can happen, right? So it doesn't always work, but it changes the probability. So it goes from a probability of 10%, maybe to a probability of 70%, because he works on it and because he can focus his mind real well. So there's lots of ways. There's lots of uncertainty and lots of things that we do. Our intent can change future probabilities. Here's one that I probably haven't talked about yet. Even if you watch my videos, you probably have this one. I heard a story some time ago with some people, it was a family, brothers and sisters. Their elderly mother died, and when she died, the children went into the house to kind of divide up the things and who got what and what was important. And they couldn't find something that all of them were very interested in, was a real expensive, old, beautiful ring that Grandma had. And several of them would like to have had that. And maybe they would have had to sell it and split the money or whatever, but they couldn't find it. It was gone. And of course, very soon they started accusing each other of having found it first and put it in their pocket, right? So they went through weeks and weeks of this hostility where now they were all disliking each other. They were all really angry and upset with each other. Terrible family relationships were going on. These brothers and sisters who had been close were now squabbling and fighting because each one of them thought the other one had stolen something from them. And then, one last time back through the house, there it was, sitting right on the shelf, right in plain sight. There was that ring, you see? So the person that saw it, they told the rest of them, and they had the ring. And each one of them thought, well, whoever it was, we finally made them feel bad, and they put it back, you see. But that was a lesson for them. That was a lesson in loving and caring. That's a lesson in value. What was important, their relationships with each other, or the money, or that ring, or the status, you see. There was this lesson going on. That's part of the synchronicity. You see, the larger consciousness system can do those kinds of things, can nudge you. And there that ring was, right where they probably all swore that they had looked there and it wasn't there, and there it was. See, so things like that can happen. So it's a very interesting reality that we live in. It doesn't mean that these things can't be just circumstance. They can be. You can have just a lot of circumstance. We do weird things every day of our life. There's things that we do that 2 years earlier we never could have predicted that we would have been doing it. So that makes it a really strange event for us. Life is like that. So things are just circumstance, but some things are not. And you generally know the difference depending on how often and how consistently they happen to you. All right, the last one I have is the backwards causality. I like this one. I'm gonna do the short one this time. What they did is put a radioactive source and 2 Geiger counters on either side of it, let them count. Now, a radioactive source works by just randomly firing out particles, radiation, in random directions. So if you have a Geiger counter equidistant away on either side of it, each one of them will eventually have about the same number of clicks because it's about as equally likely it's going to send it out this direction as that direction. All right, so they just let that sit there and calculate clicks. And then they take that data, put it away, do another one. Take that data, put it away, and have all this data put away, like experiment 1, 2, 3, 4, through 20,000, say. They just do all these experiments, they have all the data. Then they get people who can focus their mind and their intent to try to bias the data. And say, all right, here's experiment 1. Try to make more counts in Geiger counter 1 than in Geiger counter 2. We want more counts to be in 1, okay? And they put their minds to it, and sure enough, you got more counts in Geiger counter 1. Well, anybody could say, well, sure, there could have been more or less. That's a 50-50 chance because you're not going to get exactly the same number. One's going to be a little different than the other, and there's a certain statistical uncertainty about, what that, depending on how many counts you got and how much data you have, what that uncertainty is. So that's not particularly, amazing. But then they asked them to do it again, and it worked again. They wanted more counts, they got more counts. And they wanted more counts, they got more counts. So if you do that, say, 10 times, well, now you have something that is amazing. Because naturally, whichever one got more counts, it's like a 50-50. It's just, if you did, say, 1,000, wait until you had 1,000 counts, well, one of them would have, 999, and the other one would have 1,001. It's just like that. No big deal. But if every one of them, of these 10, have just a little more in Geiger counter number 1, now it's like flipping a coin 10 times and getting heads every time. See, that's not likely. Well, they've done these experiments with random number generators, and it's easy for any of you who want to do these experiments. Get a random number generator, generate a bunch of random numbers, and do the same thing. Before you look at them, before the measurement is made and the data is in this reality, you see, it's just like the double slit. It's still in the future. It's just future probability. You can change the probabilities. So you can make that probability so that this one has a little more. Now you can't make it so this Geiger counter doesn't get any and this one gets all 1,000. You see, it won't work because you can only change it within the natural uncertainty. You can bias it within the natural uncertainty. So you can bias it up just a little bit. That's within the natural uncertainty. But you bias this one up a little bit and that one up a little bit. You see, you do a whole bunch of them consistently. Now you've done something that has broken the rules of objective causality because you shouldn't be able to do that. If you did 1,000 of these tests, 500 of them should be that number 1 got more, and about 500 should be that number 1 got less. But if 400 of them that number 1 got more, now you're doing something that's really several million times to 1 that it could be chance. So they do these sorts of experiments. It's done with hospital patients. It's done with random number generators. It's been done lots and lots of time. It's done not because you've changed what happened at the Geiger counter. What happened at the Geiger counter happened at the Geiger counter. That's done, just like in that double slit experiment. It's done that you've already taken that result, and then you turn around and erase the data, and then you get the other result, you see? As if you hadn't taken that, as if you never took the data. The Geiger counter did whatever it did. What you changed was the results. And how could you do that? Because there's no information that actually said what that Geiger counter did, you see? Nobody knows. That's like the particle that wasn't measured at the slit, okay? So you're not changing, they call it backward causality. It's not really backward causality. Using your mind to change those numbers doesn't make what happened in the past change. It makes what hasn't happened yet in the present is still in the future change, you see? So if you're a scientist and believe in objective causality, that's impossible. You can't do that. But that happens, and those experiments have been done many places, many, many times. Okay, so that's the false appearance of backward causality. And one other one I'll mention is that Bill Tiller is a physicist, and he's done some research, and all of these things I'm telling you are on YouTube. The things with the radioactive decay and the hospital stays and other things, you can find these things on YouTube. But Bill Tiller has a YouTube thing where he has somebody sit down and take a beaker of water, tap water, measure its pH. It's about 7. That's neutral. And then with their mind, they try to raise the pH, or with their mind, they try to lower the pH. And he has gone as far as like 1.5 to 2 pH. That's huge. pH is a real big measurement. If you move by 1/10 of a pH, that's a lot. A whole pH is really huge to change the alkalinity or acidity of water that much. And he's done this, and he's repeated it, and he's documented it, and he's done all that kinds of things. And of course, he doesn't know how it works. He just knows that it works. Well, the way that it works is that there is uncertainty in the pH of that water at any instant time. pH isn't 7.0 with 100 zeros after it. The pH of the water is changing because you have little hydroxy ions combining, breaking apart. You've got water that comes unglued, you've got pieces that go back together. That that thing is a volatile thing. It's stable, though. It stays around 7 because there's as much combining as there is breaking up, and it keeps the pH. But if you look at it at a micro scale, that pH is going up and down and up and down, and it's like this. There's a lot of uncertainty at any instant in time exactly what that pH is at the tiny little micro level. Well, in as much as you have that uncertainty, you can bias it. Make it just a little bit on the upside. And so there's not as much down as there is up. There's more up than down. And then you can bias it a little more. And then you can bias it a little more. And you can keep biasing within that uncertainty range, a little more and a little more and a little, so you can just run that pH up. And that you couldn't sit down and in 5 minutes make it go up, by pH, by 1 whole unit. Couldn't do that because that's more than what the natural uncertainty will allow. You see, that's the psi uncertainty principle, says you can only change things within the natural uncertainty. So that's how those experiments work. A mind can manipulate things. Dr. Emoto, his ice crystals, his ice crystals don't really love Beethoven. His ice crystals respond that way because Dr. Emoto likes Beethoven. You see, the way ice crystals freeze, there's lots of random ways. You've heard no two snowflakes are the same. When you freeze water, there's all sorts of ways those crystals can come out. Lots of uncertainty. You apply your mind to it, you give it some concept, you can make it come out the way you want. More often than not, you change the probability of the way it comes out. Okay? So that's how these things work. It's just the mind modifying the probabilities, the future probabilities. Okay? So as always, I like to end up saying, it's up to you. You look at this, listen to me, and a lot of it sounds very fantastical. Yeah, okay, the bear eats a guy and somebody else goes back and the dead tree's not there anymore, and all this stuff sounds really kind of crazy. But the neat thing about it is that it does good physics as well as good metaphysics. It solves a lot of problems. You derive why C has to be a constant, which gives you relativity. You derive why particles are probability distributions. Well, everything's a probability distribution. So are those random number generators. So are those numbers of counts. So is the tree standing in the woods. They all derive first from probability distribution. So is the oxygen in the air that we're breathing. You see, everything's like that. It's all that way. So, like Darwin's theory, the only thing that makes Darwin's theory credible is that it fits the data. You get all this data, and it fits it. It explains how all these various things happen, from the different colorations of critters to everything else, suddenly has an explanation. But it doesn't, you can't explain step 1. Where'd that first cell come from? Nobody was there investigating when that first cell came from someplace. So it doesn't answer that, but it fits all the data, so that gives it credibility. This is the same. There is no, where did that first potential, information come from that was self-aware that it had a this way and a that way that grew into a 1 and a 0? Nobody was there with a microphone and a camera to interview it, so you can't say that, but it fits all the data. It answers all the questions. So that's basically where the credibility has to come from. But when you look at it, I don't want you to believe it because I tell you. I don't want you to disbelieve it because I tell you. That's the wrong approach. I really want you to find out. It's not that hard. There's lots of uncertainty in this reality. You can use your mind to do things that will eventually prove it to yourself. And how does you do that? Statistics. Because you can't prove it to yourself with a one shot, because consciousness is subjective. And the only way you can do science in a subjective world is with statistics. That's how drugs are found out if they work, because it's the real world, it's people. Somebody says, I'm better. Well, maybe they just got better anyway. Maybe it didn't have anything to do with the drug, you see? So it's subjective. So this is the same way. So you're going to have to practice doing things that create evidential data so that you know whether your mind is having that kind of effect. And if it does, then you know you're violating, the normal view of the world and reality, and then you know that maybe this is real. Maybe there's something there. So what you have to do is not believe me or disbelieve me, but go find out. Go spend 6 months or a year working on it. And by then, no doubt, you will have plenty of data to make a decision whether, I'm nuts or whether I know what I'm talking about. But it has to be your experience before it's your truth. There are advantages to having these experiences, but it's not necessary. It's not a necessary condition, but the advantage is that it's an experience. One, it gives you another reality frame in which to have experience. It's all about experience and making choices. You have two frames now that you work in, and that's this awake frame and your dreaming frame. Those are two reality frames that you have experiences in. And you can have different kinds of experiences in those two different frames. That's why you have the two frames. There's some things you can do in the dreaming reality that you would never experience here, at least you'd hope not to experience here. So you have those different sorts of experiences, different places. And out-of-body reality is another place where you get to make decisions. It's another kind of reality to operate in, so that's another set of decisions and growth potential that you can have. Not necessary. It's not even necessary that you ever remember any of your dreams, but it's available, and it'll teach you something significant if you convince yourself that it's real, and you do that by collecting evidential data. Once that's the case, then it's a mind opener, because there you were, and you were out of body, and you found yourself over, at your best friend's house, and you noticed that, something was wrong, or this or that, or what was going on, and then you go ask your best friend about it, and they said, oh yeah, that was really weird. That was the night that 6 people came over, and the house, the wastebasket caught on fire, and all this stuff, and you saw all that, you see, and it's very unusual. And suddenly, that's evidence. Now you have a verification that your out-of-body state was actually a real, it wasn't just your imagination. And learning that, knowing that, gives you confidence that what you're thinking and what you're doing and this reality that you're in is actually like that. It's not just you're not making it all up. Because that's one big decision everybody has. Am I making this up? I have this out of body. Did I just make that up, or is that real? Well, the only way to know is to work at it long enough that you collect real data. And the big mistake that most people make is they work at it for 2 weeks, they have no success, or they have maybe a little success, and then they just play around with that success, but they don't actually work at it. They don't do experiments. They don't collect data. And then it just kind of goes away, and it doesn't mean anything to you. So it can mean something to you if you use it to help you understand what's going on and how it works. And besides, it can be fun. It's an interesting thing to do. You can learn a lot. So yes, I'd say it's a valuable thing. It's a valuable thing to do, but it's not a necessary thing to do. There's nothing about having an out-of-body that will make you grow up and become love. You still have to make those choices. You still have to grow up. You still have to do the work. It just gives you another set of choices to work from.
As an average person, how can I benefit from this information?
Everybody can benefit from this information because if you know the game that you're playing and you know the rules, you ought to be better at it. If you just, if you had no idea, if you were from Mars and you had no idea what the game of baseball was about, you just couldn't understand at all what these people were doing, running around, throwing sticks, and balls going this way. It just made no sense to you, and suddenly said, you're in the game. Well, you wouldn't play very well, would you? Because you wouldn't have any concept what to do or why to do it or how to do it. Well, this is the same way. What the advantage this gives you in understanding that this is a virtual reality, that you are part of consciousness, that your goal is to grow up, become love, to lower your entropy. The fact that you know all this now tells you what the game is and how you're supposed to play it. As long as you're just muddling around and doing things kind of as they come and don't really understand that, you're not going to make very good progress as far as lowering your entropy goes. You're not going to get very far because you're not focused. So that's that's the advantage of knowing it. Now, knowing this intellectually isn't going to help you a whole lot if you don't do anything about it. If you don't actually make the effort to reduce your ego, if you don't make the effort to get rid of fear, then the overall effect is negligible. So the average person or somebody that says, listen to this, what's the benefit? It should make your consciousness evolution more directed, more focused, and more effective. And what's the benefit in that? The benefit in that is that your whole life here gets better and better, more rewarding, happier, more satisfying. That's really the benefit in it, because when you're going with the stream rather than trying to swim against it, life is just better. It's easier. You find that things happen for you, to you, with you, that are supportive. The system wants to help you. So here you are helping yourself. You're trying, you're making an effort, and suddenly everything falls into place. Things just work better for you. The synchronicity, works for you. Things happen just as you need them. Relationships are better because you understand it's not about you, it's about other. So your life gets better. Just like those people we had, the group that was based on fear and the group was based on love, which one would you rather be a part of? What difference does it make to the average person which one of those groups that they're in? It makes a lot of difference. Your life is a whole lot better if you're in the group that's based on love. So it makes your life better, makes your existence more fun, gives you more joy in your existence. You feel satisfied. So yeah, there's a lot of good reasons that this is helpful.
Are our goals or intentions restricted to our own potential, or do they affect the whole human record?
So the way I interpret that is when we have our intention to change the probable reality, when we're using our intention to grow, is it just us? Can we only affect ourselves? Is it only us that we can work on? Is it only about us, or do we affect the whole thing? And the answer is you affect the whole thing. You're a part of a whole. And whatever you do affects those around you that are connected to you, which affects those that are around them that are connected to them, and it spreads out. So whatever it is you do, it's a part of a bigger picture. And you yourself are a part of a bigger picture. And you can do things with your intent that are about you. You can heal your mother or your sister or your brother or yourself. Or you can have a bigger scope. You can heal your nation, you can heal the world, you can do that. Now, if you have a bigger target, your effect is going to be smaller. If you have a smaller target, your effect is going to be bigger. Because it's, what are you trying to change? How much mass are you trying to move, basically? If you're trying to move a whole lot of fear to that's harder than moving just a little bit. So yes, but it does have an effect. Just because the effect's small doesn't mean that it's inconsequential, or doesn't mean that it's meaningless. People who pray for world peace or whatever, they're part of the solution. They're part of the solution. Even if it's only a tiny little part, it's better to be a tiny little part of the solution than it is to be a tiny little part of the, of the problem. So it's, you do affect everything. We're all connected, we're all netted. We're all individual consciousness in the sense that we're individual. Our individuality is really part of the hallucination, but we're all part of this one consciousness system. We're pieces of that one consciousness system, but we're all interconnected. We're all netted together. It's like the internet. We can affect each other. We can communicate with each other. We can help each other. And of course, we have free will. We can hurt each other. We can pull each other down. We have the capacity to do that. That's the choices that you make that pull you up or push yourself down. Okay, this is about defining words, and these words are very confusing. I tend to break consciousness into two parts, and I'll do it on Saturday. You'll hear me do this. I didn't get in that much detail here. And that's little c consciousness and big C consciousness. And that's because we have a cultural definition for consciousness, and our culture says consciousness is what we create with our brains. It's our awareness of the physical reality, and it's considered to be brain-centered. Well, that's just that's little c consciousness. That's the way our culture looks at it. That is just our immediate awareness here. But we're more than that. And that is not brain-centered. That consciousness is really a part of the bigger system. It's a chip of the bigger system. But you have that part of your consciousness, that little c consciousness, if you will, that's the part that's kind of broken off. That's a little separate chunk that's in this game, that's experiencing this virtual reality, that's learning and growing here. That's that piece. Okay, but you are also big C consciousness. You're also just a piece of the larger consciousness system. And that's why you can take your intent and shift it to different data streams. You can do out of body, you can heal, you can do other things that aren't normal, that people do in an objective reality. You can do those things because you are part of the larger system. So we're both, but the words are very confusing because we use them to mean different things. So if you talk to a psychologist and he's talking about consciousness, he's talking about little c consciousness, your awareness of your physical surroundings. That's what he's talking about. He's not talking about the larger consciousness system. He doesn't know that exists, probably. He's just talking about that little c. So we have to be careful with words because they get confusing. In our culture, we use the same word to mean different kinds of things. Well, aging is part of the rule set. Okay? That's part of the way our physical system evolved. It gets old, it wears out. It builds up toxins in the cells. These things happen. Now, you can affect that. It's not just that if you are love-based that you won't age. You can affect that. You can affect it with your intent to make yourself age more slowly. If you want to put a lot of energy into that, you can do that. Okay, but if it's entirely ego-based, which mostly that would be, right? If it's entirely ego-based, then it's going to be very limited in what you're going to be able to do. But you can you can spend a lot of time treating your body well. You can eat well, you can exercise, you can do all those other kinds of things, and that will keep you younger, longer, keep your body functioning well for a longer time. So there's lots of things you can do to affect it. But for the most part, not getting old may sound like a good idea, but that's really not the way this is set up. It's set up so that you cycle through, learn what you can learn, and as long as you're learning and growing and real productive here, well, then good, you should continue as long as you can. But mostly by the time, a certain number of years go by, you kind of get to the point where you're ready to recycle. You've kind of done it, and you've learned what you've learned. If you're still growing a lot, then go. But I don't know that you'd want to stay here forever, for a really long time. What happens to us is we end up getting beliefs, we end up backing ourselves in corners with our assumptions, and we end up not being so productive anymore. But bodies wear out just because that's what the rule set says. You can use your mind to change that probability or slow it down, but there's really not a whole lot of point in it. Do your thing and go on and move on to the next. It's like you're afraid to change the page to the next chapter. Your existence is just like a book. It's got all these chapters in it. All right, so here's this one chapter, and you don't want to go to the next chapter. You just want to keep that chapter going on and on and on and on. Well, if it's productive, sure, but generally it's more productive to turn the page, get on to the next chapter. So the idea of staying young forever, I don't find that real appealing. You want to stay healthy and fit to do the work and do the growing that you need to do. But there comes a point where it's really more productive for you to turn the page and get on with the next chapter. It gives you new opportunities. It gives you new perspectives. It gives you new challenges. It gives you a whole new set of variables to work with, as opposed to still juggling that, that same old set along for a real long time. So one of the things we have in our culture is a fear of death. People don't want to die. They want to stay young forever. They want to live forever, and part of that's because they can't deal with uncertainty. They don't know what's going to happen when they die, or they think that it's just going to be, that's it, they're done. It's over, and they had their run, and that's the end of it. But that's not really the case. Death is really not a big deal. Death is a very small deal. It's as small a deal as turning the page to the next chapter. It's just not something to worry over or be frightened of. It's a good thing. It's part of the renewal process. New challenges, new perspectives from new eyes. You get to apply yourself in a whole new rich situation that you get to work out and deal with. That's growing. You'll learn faster that way. Your rate of growth tends to slow down when you're in that same chapter for too long. You get kind of stuck in it, and then there's no point. Now, the only reason to stay there is to just keep on keeping on. You'd be much better off to get into a new, fresh situation, and you'll learn faster. So there is no such thing as death. We don't have any more death than they do in World of Warcraft. When your lizard drowns, he's, and what do? Run back to the graveyard, and he pops back up, and you're running back out into the game. It's sort of like that, There is really no such thing as death because there's really no such thing as a physical body to die. Nothing dies. You just drop out of this three-dimensional virtual reality game, go to a different virtual reality, plan another game, another character, fresh challenges. Well, there's a couple of reasons for that. One, what you come in with is a mix of several things. One, we are evolving our consciousness, and that evolution is cumulative. So we get wiser, if you will. We get better quality, lower entropy consciousness, and then when we recycle, when we leave this and then come back on a different adventure, we come back in chapter 2, we bring that quality with us. We don't start over at the bottom. We start with the quality we've earned, and then we earned a little more. And the next time, we start with the quality we've earned there, the sum. So it's a cumulative, that's learning. It's not like as soon as you get out of second grade, you go back to kindergarten. You keep learning. You keep getting more and more understanding of what's going on, becoming love, more quality to your consciousness. So that's an iterative process. So when you come in with quality of your consciousness. Now, that doesn't mean, you come in, with an intellectual account of anything. You don't. You come in with an intellectual account of 0, basically, most of the time, and then you have to learn that. You have to re-understand, reprogram how to interpret this reality. Okay, we start over with infants, and we do that, but the quality is there, and you pick it up much more quickly, and you get to the point where you are now sooner, and you pick up more things. You see, that's kind of because it's a cumulative thing. The other thing that's happening is that there's a lot of uncertainty in a conception. You've got all sorts of ways that those chromosomes can interact with each other and what they can produce. There's billions and billions of outcomes that can come out of taking 26 variables and making combinations and permutations of all those things. So some of it is just variation by chance. Some of it is what you come in with. Some of it is good luck in the sense that maybe you just get nudged or bumped or are lucky to be in a situation where it helps you learn. Maybe that's pain. Most of us don't learn when we feel happy and good. Most of us learn from pain. That's unfortunate about us. If you grow up a little more, you get a little higher quality consciousness, you don't need pain to grow up. You can kind of grow up without the pain. When I say it makes your life happier, that's one of the ways it makes it happier. But for most people, unless you get a real hard, swift kick, you don't pay any attention. Most of us, if everything's going just great, well, we just lie back and enjoy it. Why work? Things are good. We don't keep at it. Whereas if life is tough, we start thinking, how can I make it better? What can I do? What I'm doing wrong? You start working on it. So that's but some situations are better than others. Sometimes that smack between the eyes that you get with the pain is the best thing that could happen to you. It gets you going in a new direction. It lets you pick things up and make new choices. So it's not always clear that your life is terrible or that it's beautiful. What matters isn't the money you have and the designer clothes you wear. What matters is how you've grown up. That's the purpose. So you can focus your time on evolving your quality of consciousness, and then let everything else take care of itself. And you'll find that everything else takes care of itself in a way that just makes you happy as can be. That's just the way it works out. Yeah, why? What you see is what we are. When you turn on the nightly news and all you get is death and destruction, well, that's partly the bias of the nightly news. That's all they ever report because that's what gives people, that's what makes people turn the channel on. Fear. Fear is a big motivator. But we are who we are. What you see out there is a representative of us. That's really us. That's the way we are. That's the level of consciousness we are. We're full of ego. We're full of fear. It's about us. If we don't have it, we want to take somebody else's. That's just at the level we are. So that world you see out that's that awful, that's the way humanity is. This is not a graduate school. This is a daycare for budding consciousness. We are not advanced. We are struggling. And yes, there's been times when it's been, and places where it's been nicer, and there's been a lot of times and places when it's even been meaner than it is now. So it's uneven. I think that it's been getting better. I think if you look at the big picture of the evolution of consciousness on the planet, I think you're going to see a slight uptrend, slow but getting better. I think we are evolving as a species, but I think that trend's a little hard to see because the way the curve looks is like this. You know, it's bumping and jumping all over the place, but I think the uptrend is that we are evolving. You know, our culture right now is based on fear a lot more than it was when I was a child. We're a lot more fear-based. When I was a child, I was 7, 8 years old. My mom would say, go out and play, come back before dinner. You know, now a mom wouldn't let their child out of their sight for more than about 5 minutes unless they were, locked in their own backyard or something. But I'd get on my bicycle and I was gone. They had no idea where I was, and I was having fun wherever it was. I'd be 5, 10 miles away doing things with people, whatever. And that's all right, as long as you're home by dinner, otherwise you're in trouble. But couldn't do that anymore. See, that doesn't work. There's too much fear. We're not the same culture that we were, and you say, well, that's backsliding, isn't it, with all this fear? Well, some ways it is. But then look, when I was young, there was so much conformity, so much conformity. Guy couldn't even wear anything but a white shirt. That was it. If you didn't wear a white shirt with your suit, there was something wrong with you. If you worked, my dad worked in a business, he had to wear a gray flannel hat, period, whether he wanted to or not, because that was the uniform. Everything was buttoned down. Women couldn't wear pants, go on and on. And we say, well, okay, that was a time though the kids could go off and play and nobody was worried about it. But all in all, so there's lots of things that are up and down. A lot of ways right now, we're on the edge of a lot of freedom that we've never had before as a race. That freedom comes in the form of an internet. That internet gets us huge resources. That internet gives us opportunity that we never had before. Now you've got you've got a product, something you do, some services you can perform, market it to the world. Put it up there on the internet. And if it's good and people like it and it's useful, your business will grow. Before, you'd have to go find one of the big boys in the corporation to sponsor you. You're a musician. Well, if the big record label didn't pick you up, you'll never amount to anything. Well, now you're a musician. Get on the internet. People like your music. They'll buy it. You'll get to be popular. You'll make some money. And then the big boys will want to come and pick you up. You say, you couldn't do that before. Like me, you write a book, put it on the internet. If it's good and people like it, they'll buy it. You don't have to go through, big publishers. It's not important anymore. Anything you've got to say, you can say it. And if it's valuable, people will read it and come back for more. So we're on there's a lot of freedom in that. There's a lot of ability for the individual to shine and to kind of do their stuff and be appreciated, whereas before, oh, you don't have the right credentials? Sorry, you can't join this club. Oh, you're not, you don't have the right suit, you don't have, whatever. You're not the right sex, you're not the right race, you're not, whatever. Sorry, that door's closed. Well, it's not like that so much. The internet's a big leveler, and that's a huge plus up for freedom. So there we go, and at the same time, our politics and our religious state, we got all this fear going on and people want to kill each other, and that's gone the other way. So it's what you see out there, this kind of miserable state of humanity is because humanity is in a miserable state of being. We just need to grow up. That's why it's so important that we grow up our quality to at least match our tools. You see, we grow up our tools, our weapons of destruction and so on. We grow up our ability to affect things physically while we're still infants. We're still in daycare emotionally and spiritually. That's a problem. That's dangerous. That's like giving a 3-year-old a loaded gun. That's a dangerous situation. So yes, that's been getting worse as far as uncertainty goes. That what you see is what you get. That's who we are. We're not much better than that. That doesn't mean there aren't some beautiful, loving people in the world. There's lots of them. But there's a whole lot that are full of fear and full of ego. And those are the ones you see on the nightly news. Okay, we probably should end it up. Thank you all very much for coming out. I hope you've learned something useful.